This is a chemical reaction. It's quite simple. You've seen it in a video. Okay? Of pure sodium, which is a metal. It's on the left-hand side of the periodic table. Column 1, it's an alkali metal. Okay? So it's number 11. And it's being dropped into liquid water. Okay? Does anyone remember what that reaction actually ends up looking like, where you take pure sodium and you drop it in water? Grace? Yeah, it goes boom. Okay? It goes boom because of the way that it reacts. Now, notice there's not any fire inherent here, but what's happening is this. Sodium comes in, takes hydrogen out of water. Okay? However, in doing so, it takes its place. So it's the sodium then bonds with the oxygen. So I have a metal, non-metal. What kind of substance is that? Metal, non-metal. It's not covalent. Ionic, right? Because you have that metal in there. Covalent substances would be those substances like water, which only have nonmetals. Okay, so kind of bringing in some review. So we have an ionic substance here called sodium what?
Sodium
oxide. And it's going to then also, the hydrogen has to go somewhere, so it comes out as a gas. H2, it's one of those H2. It's one of those diatomics that we were talking about. Diatomic meaning two atoms. Reagan.
Okay, well, if it's like H2 or like O2, does that mean gas? Like if it... Okay, so 2 stands for gas.
Yeah, so 2 automatically implies it's coming out as some kind of gas.
Okay.
Okay? And so I wrote it out for you. We have sodium dropped into water, reacts to produce, that's what the arrow here means, sodium oxide and hydrogen gas. Notice, the same 3 elements are on both sides. What are those elements?
No.
Miss Lixon, what is this element?
Sodium.
Ah, bravo, senorita. Yes. Okay, and what's the next one?
Water.
Well, water's not an element. It's a substance, it's a chemical. What makes up water?
Hydrogen and oxygen.
Indeed it does. Hydrogen and oxygen. And because the laws of the universe dictate under the conservation
laws of the universe.
of mass, states that what I start with, as far as the number of atoms, is what I have to end up with. I have to end up with sodium, hydrogen, and oxygen. But it can rearrange itself. Okay? It can rearrange itself. I'll give you an example. Bo Behrman, come on up. Noah, come on up. Isabel, come on up. And Gloria, come on up. Okay. Bo, I need you here. Izzy, I need you next to Bo. Noah, I need you right here. And Gloria, I need you next to Noah. Okay? And scoot over that way a little bit. And you two scoot over this way a little bit. There we go. All right, perfect. Now, we have relationship 1 and relationship 2. Okay? Now, okay, it's not real, ladies and gentlemen. It's just an example. Grace Pennicamp, I see your silly face. So, we have relationship 1 and relationship 2. I'm starting with a Gloria, a Noah, an Isabella, and a Bo. Okay? However, so when my reaction takes place and there's major relationship disruption, which is about to happen, mind you, I'm going to end up with something new. New relationships, same people. Okay, so what I start with, I have to end up with. I can't start with an Izzy and ends with a Lexi. Okay, it doesn't happen. Okay, I start with an Izzy, I end with an Izzy. I start with a Gloria, I end with a Gloria. I start with a Noah, I end with a Noah. I start with Bo, and yeah, I know, I end with a Bo. So, here's what happens, right? We have our reactants here, relationships, reactants, okay? And reaction takes place. Switch. No, not you. You're over there. Okay? Right, get over. There you go. Okay? And voila! New relationships, new pairings. Same people, right? Izzy, Noah, Gloria, Bo. Same people, different pairings. That's what's happening in a chemical reaction. We take a bunch of stuff, we rearrange it, it becomes new, but what we start with, we really end up with. It's just been rearranged. That's the whole idea of a chemical reaction. You can go ahead and sit down. Thank you. Okay, so that's what we're doing here. We're taking chemicals and kind of mixing them up and making new chemicals, but we're using the same ingredients, the same elements. Okay? So, how many sodiums do I start with over here? Yeah.
1.
1 sodium. And you can see down here that this is a sodium atom. Okay? That's what I'm starting with. How many hydrogens? How many hydrogens? Yeah.
2.
2 hydrogens, yeah. H2. And you can actually see them here on the water molecule. There's an H and there's an H. Okay, how many O's? Yeah.
1.
1 O, okay? And so we see that's kind of the big central atom right here. Okay, so I have a sodium, an O, and 2 H's. And this is how they exist in nature. So they react. Okay, they react. And they end up with sodium oxide and hydrogen gas. Sodium oxide, this is the chemical formula for it. I can't change the chemical formula because that's what it is. And H2 exists in a pair. That's what I have to work with. So now we have to count up our atoms and see if it's the same. How many sodiums do I have here? Yeah.
2.
2 sodiums. How many hydrogens? Well, Behrman?
1.
Really?
2.
2! Thank you. Yeah. See this? I have a sodium, oxygen, sodium, so Na2O. And I have hydrogen gas over here. It's kind of a little bonded molecule. So, and now I have 1 oxygen. So, I have my equation. It's written with the proper chemicals, the way they would combine in nature. I'm counting up my atoms, and I have to ask myself, does the conservation of mass hold true? Am I using the same amount of ingredients on the left and right? And the answer to that is no, I am not. I've got more sodium. Somehow the universe is like, okay, sodium. No, that's not what happened. I can't just end up with a sodium. I just can't have it come out of nowhere. Okay?
I can't see down there. Thanks.
I can't have it come out of nowhere. It's got to be there originally. So what can I change to make sure that I start with 2 sodiums? Because I have to end with 2 of them. What can I change? Yeah, Jade.
You change the big number before the sodium to a 2.
Right. If I make it so that I have 2 right from the get-go, then that means that I can change this here to a 2.
How can you do that? How is that?
It just means I have, so instead of having 1 tablespoon of sugar, I just have 2 tablespoons of sugar.
But how are you allowed to do that? Because the cake wouldn't work on the other side if you were doing it with ingredients. Because you had the first one,
Great.
and it worked out perfectly, but then the second one didn't.
No, I'm saying these are the chemicals I start with. I just have to decide whether I need 1 of those or 2 of those. So like I'm looking at a cake recipe, and it's calling, and I want 2 cakes. Well, I know I need to double the ingredients. Same thing here. This is what I get. I know to get this, I'm going to need to double this guy. So instead of 1 sodium,
You have 2.
I have 2 sodiums. And now that I have 2, this molecule can actually form. Okay? So now I have 2 sodiums, 2 hydrogens, and oxygen. 2 sodiums, 2 hydrogens, and oxygen. I have the same number on both sides. And it's balanced. Now, there is a difference, and I think it's part of the discrepancy here, is why can't you just do this? Can't do that. No. Okay? Here's why. If I had 2 Na, that's saying I have 2 separate sodium atoms. It looks like this. Okay? Na2, however, which doesn't exist, by the way, it doesn't bond with itself, would look like this. Okay? It'd be 2 bonded together. See, there's a difference. 1 indicates no bond. 1 indicates a bonded molecule. So we do have to be careful how we write it. In this particular case, I need 2 separate atoms because that's how sodium exists in nature. Sodium doesn't exist like this. So that's not how we write it. And I'm not expecting you to know that. I'm expecting you to be able to look at this and say, oh, that is a bonded molecule. This is 2 separate atoms. That's what I'm going for here. We're going to practice this today. This is all it is for notes today. All right. Here we go. This is PhET. It's a website designed by the University of Colorado to help walk you through different ideas. We've used it before, so let's go ahead and do this. If you would please zoom in or click on the little icon here. It says HTML5 Sims. Okay? Okay. So if we need to look at that again, okay, it's right here. All right. So click on that.
Which one?
HTML5 Sims. All right. Now, once you're to this page, okay, we are looking for this right here. Okay, so it's called balancing chemical equations. Okay, so you see where my little icon is kind of focused there? I can zoom in. Go ahead and click on it. And what it's going to do is it's going to load this particular icon. We are going to start with the introduction. So if you would just tap it, it's going to bring you here. All right, there are 3 different scenarios we can walk through here, okay? We want to prepare each scenario properly, however. So what I want you to do is find the Tools menu in the upper right-hand corner. Okay, so right here. And I want you to go ahead and select the balance. Okay?
Wow.
Okay, now, any chemical reaction has to start with at least one of everything. So what we're going to do is we're just going to tap so that everything has one coefficient to begin with. Notice how we cannot...
Where do we tap?
See the little arrows here? So you tap the little arrow, kind of right there. Right there, right there, etc. Okay, so mine's going to reload here real quick so it kind of cleans everything off. I'm going to go to Introduction. And there we are. All right, now, so I'm going to go ahead and make sure I have one of everything. And this is how it works. You count the atoms. So notice, oh, I need my tools, my balances. Notice my balances. Are they balanced?
No.
They're not. The balances indicate your atoms. So I have nitrogen and hydrogen here. I have N2, H2, and NH3. Okay? On which side do I have more nitrogen? On the left or right?
I can't tell which one's nitrogen.
Where it says, you see the big N?
No, I mean, which one's the 2 or 1? Which one's the nitrogen?
They're both nitrogen.
Oh, okay.
This is all nitrogen. This is all hydrogen.
Then why don't they just combine them?
But they're not. They're looking at the atoms individually. The whole idea is that we can look at the atoms individually. Notice here we have N2, that's the chemical we're working with. H2, that's the chemical we're working with. They combine to form NH3. But the problem is I have more nitrogen on the left than I have on the right. So where do I have to add nitrogen? Where do I have to add nitrogen?
The left.
On the right-hand side. So I go ahead and I increase the NH3 to 2. Okay? Like so. Okay, is my nitrogen good? Yeah! What about my hydrogen? Okay.
You have to step it up.
So, Bo Behrman, you see the left-hand side here of my scale? I have to add more to the left. So, you see where it says H2 right here?
What are we making?
Okay, I have to increase that, not once, but... Okay. So...
Mine's not working. Yeah, neither is mine. I've tried it over and over.
Okay, what I want you guys to do, for those of you that have it working, is go to Separate Water and try this on your own, okay? Go to Separate Water and try this on your own.